Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in physics and clear your all doubts and confusion. Today we'll discuss one very probable board examination question, capacitance of parallel plate capacitor. And if you won't devote next 5 minutes on this video and receive the similar pattern question in your board examination, then won't say I left behind, फिर ना कहना रह गया. Our probable board examination question is derive expression for capacitance for such parallel plate capacitor. So let's first understand what is capacitor. Capacitor is made of two separate non-touching conductor plates which are insulated by a dielectric insulating media. Now such configuration can build and retain charge when we apply external voltage across these plates. Now this property to build charges on plates when voltage is applied and the same charges get retained on this configuration even when this external voltage is removed is known as capacitance, and this take place because this insulating dielectric media get polarized, and in this polarized state it can hold charges on conductor plates. The charges, which are equal in magnitude and opposite in polarity, are stored and retained in capacitor configuration when we apply voltage, and the amount of charge stored and retained is directly proportional to voltage which is applied across conductor plate, and this proportional relation can be converted into equality using a constant, and this constant capital C is called capacitance property of this capacitor configuration. We can define capacitance as ratio of charge stored on conductor plates to voltage applied across capacitor plates. So we can say charge stored and retained per unit of applied voltage is capacitance, and a capacitor configuration which can store more amount of charge with less amount of applied voltage got higher amount of capacitance. Capacitance is measured in farad unit. This parallel plate capacitor is the simplest form of capacitor, and it is constructed using two parallel metal films or metallized foils which are spaced or separated by a certain distance using a dielectric insulation. So there are two conductor plates in the form of film or foil, and it is separated by a insulating dielectric media, and this dielectric media can be either air, paper, oil impregnated paper, polyester, polypropylene, ceramic, or some other variety of insulating material. When two parallel conductor plate got equal and opposite charges on them with identical surface charge density, they will produce a uniform electric field in between conductor plate in the dielectric media, and electric field is directed from positive charge plate to negatively charged plate, and amount of electric field is given as ratio of surface charge density on conductor plate to permittivity of dielectric media. The surface charge density is charge per unit area, and permittivity of dielectric media is permittivity of air or vacuum multiplied by relative permittivity of dielectric media. So electric field is given by this expression where Q, A and sigma are respectively charge on conductor plate, A is area of conductor plate, and sigma is charge per unit area of conductor plate or surface charge density on conductor plate, and epsilon is absolute permittivity of dielectric media and epsilon r is relative permittivity of dielectric media, where epsilon naught is permittivity of air which is 8.854 into 10 to the power minus 12 farad per meter, and this expression clearly indicate that for given surface charge density on conductor plate, the electric field in dielectric media doesn't depend upon plate separation. It depends only on surface charge density and permittivity of dielectric media. So in parallel plate charged capacitor, uniform electric field is given by this expression, and in this uniform electric field with D separation between plates, the potential difference between plates in uniform electric field is given as product of electric field intensity multiplied by plate separation, and this would become expression for potential difference across two capacitor conductor plates, and capacitance is defined as charge stored or retained per unit of applied voltage when Q is divided by applied voltage, and terms epsilon naught, epsilon r, area of plate and plate separations are transformed to a other side. This will give an expression for capacitance as epsilon naught, epsilon r, A over D, and this clearly indicates that capacitance of this configuration depends upon relative permittivity of dielectric media, area of conductor plate, and separation of conductor plate. So for this parallel plate capacitor, the value of capacitance or charge stored and retained per unit of applied voltage is given as epsilon naught, epsilon r, A over D. So it clearly indicates that capacitance of this configuration is directly proportional to size of conductor plate area, and it is directly proportional to conductor area. Capacitance is directly proportional to relative permittivity of dielectric media, and higher epsilon r material got higher capability of being polarized, and higher epsilon r could retain higher amount of charge for same amount of voltage, so that would have proportionally higher value of capacitance. If in place of air we place mica with epsilon r 8, then capacitance of air capacitor with mica dielectric media become 8-fold. This capacitance is inverse proportional to plate separation. If we reduce plate separation to half with the same plate area and same dielectric media, capacitance will become double. The capacitance of parallel plate capacitor doesn't depend upon shape or material of conductor plate, and it also doesn't depend upon the amount of charge or potential on conductor plates. We hope this small video has solved one of your board examination problem. If you found this learning material useful, do share it with your friends. Our other learning video of Confused in Physics series are equally useful, and you can watch these learning video in our senior secondary physics English playlist. The notes of this and other important probable board examination questions are given in a link, and that link is available in the description. Happy learning. Have a nice time. Thank you very much.